let's discuss reflection of wave pulses in a stretched string. Say, if we're given with a string which is clamped at one end on a wall, and say this end we oscillate, or we provide half oscillation to it, it produces 1/2 of wave pulse, which propagates in the string, and which when incident on the wall will be reflected. And here we can treat this string as medium 1 and this wall as medium 2. As we know the wave can never enter into the wall, we can write v2 is equal to 0 and v1, the velocity of wave in the string, can be written as √T by mu, which we can calculate. So in this situation, as v2 is 0, correspondingly if we calculate the transmission and reflection coefficient, here transmission coefficient will be 0, which is 2v2 upon v1 plus v2. And the reflection coefficient is -1. That means the whole energy is reflected back. So, let's see what'll happen if we produce a wave pulse in a string, which will propagate with a speed v1, towards the wall. After reflection, as AR is -1, the reflected wave will be having 180° out of phase with incident wave. So we can say it'll be reflected in this manner. From here, it'll be reflected in the reverse fashion and it'll be propagating with the same speed v1. This is the way how the wave is reflected from the clamped end of the string on the wall. And this similar situation might occur when instead of wall there's a heavy string connected. Like, say we're given with the situation that there's a string which is connected with a heavy string, and these two are clamped at their ends. Say, if a pulse is created which is traveling with a speed v1, we know the speed v2 in the heavy string will be less than the speed v1, because linear mass density is more, so speed will be less. So when the wave pulse is incident on the boundary of the two strings, a part is reflected and a part is transmitted. And obviously, as it is reflected from a denser medium, it'll suffer a phase change of pi radians. That means it'll be reflected in an inverted manner. So situation would be this. And, on the forward side, the part which is propagating, it'll be in the similar fashion in which it was incident. This'll be the part of wave pulse that is propagating with the speed v2. And the reflection occurs with the speed v1. This is inverted because v2 is less than v1. So here, reflection coefficient will be negative. And the transmitted part of wave will be above the length of the string, because transmission coefficient is positive. Say if the situation is slightly different, like if the pulse is initially coming from the side of a denser medium, like if this is a pulse which is traveling with a speed v2, it is incident on the boundary where on the other side the string is lighter. Then we can say, in this situation, when the wave is reflected as well as transmitted, we can say, the reflected pulse will also be in the same direction, because we can state in this case as v1 is less, or the velocity in second medium is less, the wave velocity will result positive reflection as well as transmission coefficient. So we can say here, reflection coefficient is positive as well as transmission coefficient is positive. So when the wave coming from the side of denser medium incident on the boundary, it'll be reflected as well as transmitted in same phase. This is the way how we analyze the reflection and transmission of wave pulses on a stretched string. It can be clamped on a wall, it can be attached with other strings. So such situations we need to take care. Whenever based on similar situations problems are there, we must use it.